Hi, welcome to the Mathemagic channel. Today we look at how many non-prime factors 2020 has. Now this is a question from Math Olympiads from 2020. And the reason I really like these kinds of questions is because they use factor theorems, which are not traditionally taught at school and which rely on prime factorizations. So I really enjoy these types of questions and I hope that you do too. So without further ado, let's jump right in and try this question. Let's go. So as I mentioned just now, we will need to use factor theorems, which are going to rely on the prime factorization of 2020. Now, if you are not sure about how to factorize a number like 2020, you can always use factor trees. Factor trees go a little bit like this. You write the number down and then you say, okay, I'm going to divide this by 2 because it's even and it's the first prime number. And so I'll put a 2 in a bubble here and I'm left with 1010. And 1010 is still even, so I'm going to divide it by 2 again. So this is a factor tree. And if I do that, then I'm left with 505, which is not prime yet, so it doesn't go in a bubble. And then 505, I can't divide it by 2 because it's odd, but I can definitely divide it by 5. Cannot divide it by 3 because the sum does not add up to 3. 5 plus 0 plus 5 is not a multiple of 3. So I'm going to go to 5, and that gives me 5 times 101. And 101 is prime, so it goes into a bubble as well. So when you look at this number here, 2020, you can actually say that that is 2 squared times 5 times 101. That is using the factor tree method, which is totally valid. I do think there is a little bit of a faster way to do something like that. So just as a side note, my preferred way to factorize a number like 2020 would just be to write it out and say that that is 202 times 10. And I'm comfortable doing this because I know that 10 is 2 times 5. So here I can separate it into 2 times 101 times 10, which is 2 times 5. And here you have your prime factorization, which is 2 squared times 5 times 101. So whichever way you decide to find the prime factorization, whichever method you prefer, then it's it. Just pick. If you like factor trees, that's fine. If you like the shelving method, which is another method, that's fine. If you like to just break the number down, that's fine too. Now this question is about how many factors, and so I'd like to introduce you here to a technique which I really like, and it's about how we find the number of factors of a number. So if I give you 12, for example, and if we look at the number of factors of 12, we can list them because it's a pretty small number. So 1, 2, 3, 4, 6, and 12. So 12 has 6 factors. So there are 6 numbers which are factors of 12. Now, how would we do that given the prime factorization? And this is why I really like this question, because 12 is equal to 2 squared times 3. And if you look at the exponents here, so 2 is to the power 2 and 3 is to the power 1. And so the technique goes a little bit like this. You take the exponents, so you take the 2 and the 1, you add 1 to them and you multiply them by each other, and that'll give you the number of factors. So if I take the 2, I'll say 2 plus 1 here. And if I take the 1, which is the exponent for the 3, I'll say 1 plus 1. And to find the number of factors, I can say that that is 3 times 2, which is 6 factors. So this is a pretty cool technique, and it comes from the prime factorization. And you can do this for any number, and I really like this theorem. So again, you take the exponents, you add 1 to them, and you multiply them by each other. So the exponent for the 2 was a 2, so I did 2 plus 1, which is 3. The exponent for the 3 was a 1, so I did 1 plus 1, which is 2. And I multiplied those numbers by each other, as you can see here, 2 plus 1 times 1 plus 1. Very cool little theorem. If you don't know it, then now you do, you can use it. So if we go back to our problem after learning this theorem here, so we had 2020, which was very nicely factorized as 2 squared times 5 to the power 1 times 101 to the power 1. So notice I'm writing the exponents out because I'm going to use this for our theorem for the number of factors. And so if we add 1 to each one of these exponents and multiply them by each other, so I'll take the 2 from the 2, so I'm going to go 2 plus 1 here. And I'm going to multiply this by 1 plus 1, which is the exponent for the 5. So I add 1 to the exponent. And I'm going to multiply this by 1 plus 1, which is the exponent for the 101. So 1 plus 1 again. And this is going to lead me to 3 times 2 times 2, which is 12 factors. So the number 2020 has 12 factors. Now, these are both primes and non-primes, and you can think of factors as going in pairs with each other. For example, 1 goes with 2020, 2 goes with 1010. So there are 6 factor pairs and 12 factors to the number 2020. Now, the question says, how many non-prime numbers are factors of 2020? Well, the easy way to do this is to think, we have 12 factors in total. How many of those are prime and how many of those are not prime? Well, the only prime factors for 2020 are going to be 2, 5, and 101, because anything else, since this is the prime factorization, anything else is a non-prime factor. So we have 3 prime factors. So if we have 3 prime factors, we should have 9 non-prime factors, since we have 12 altogether. So 9 non-primes for 2020. So this is the answer to this little Math Olympiad question. 2020 has 9 factors which are non-prime, 3 factors which are prime, those are 2, 5, and 101, and 12 factors in total using this cool little trick, which is the factor theorem for the number of factors. Thanks for watching today. I hope you enjoyed this factor theorem, which I really enjoy and think is really useful. There's also a factor theorem for the product of factors. So you have 3 factor theorems: product of factors, sum of factors, and number of factors. So today we just covered one, which I really like. And you can mix and match them. There's some questions where, you know, first you find the number of factors, and then you find the sum of factors, and then you have these kind of Olympiad questions which are centered around that. So super cool kind of question, which is a little bit off topic and not something that you learn at school very often. Thanks for following. Please like and subscribe to the Mathemagic channel, and I shall see you on the next one. Bye-bye.